Hey everyone, my name is David Lopez, and today we are going to be discussing the development of probability theory. So, there's a lot of talking points when it comes to a lot of the foundational pieces that help transition things to what we know about probability theory today. But something I just want to highlight is this parallel that's drawn between the origins of probability theory to today and how we use it. And it really is just those driving elements to get people into this idea of the application and advancement of probability theory. You see, there are two big points of focus that concern people in the past, and those things were predominantly betting odds and probable outcomes for games of chance, and also analyzing demographical data and drawing inferences from things particularly akin to that of mortality rates. Now, I personally found this amusing just because whenever I hear people talk about probability in conversation, it's always in this comparative stance of one of two things, which is, usually this astronomically rare event that they describe, and then they compare it to being like, oh, you're more likely to be struck by lightning, or you're more likely to win the lottery. It seems that whether if it was in the past or today, the only things we really concern ourselves with probability is money and death. So, kind of using that talking point to transition, it was with London merchant John Grant and his collection of data from the bills of mortality that we started to make our first inferences on empirical data. The idea of gathering, collecting data is not a new phenomenon at this point, but this is the first time that it's gathered, and we're able to start making points or recognize patterns within them. Something in particular of note when it came to the Bill's mortality was John Grant recognizing two coinciding elements. The first being that women tend to live longer than men, and from physician reports, physicians claim to have had twice as many female clients compared to male clients. Uh, he was able to make a bit of a humorous stance on this in that either A, the physicians were doing their job in treating women of their ailments, or men with their vices and alternative natures were not having any medicinal regard whatsoever to compensate for the extra deaths. Um, but to kind of step away from that for a bit, we go ahead and see this transition from observing empirical data to understanding the theoretical side of probability as with the works of Girolamo Cardin, we are now stepping away from looking at things that have already happened or transpired and trying to infer on what could occur next. Instead, we are seeing the layout for things like games of chance and how they are shaped by, the different likely outcomes that could occur, and understanding that fundamentally this is the basis for how we determine percentages of success and failure, and this is something that becomes a stepping stone for future mathematicians who chose to explore different aspects of probability, one of which came from the mathematician of Pascal, who made a counter argument against the original point from Demir's problem of points, where he was trying to see what the likelihood or outcome would be of rolling two dice and getting a six on both. You see, the error that Pascal pointed out in his own proofing is this idea that you're just looking at the results for what they are, as opposed to just looking at each event or each dice roll in isolation. And the way he kind of proved his point was, imagine if you took two dice and instead of just rolling them, you painted one of them red and the other one green, and then you proceed to record all the different outcomes. Now there's a new layer to this because even though we may not initially concern ourselves with which die value is which, doing so shows that sometimes this repetition is apparent and it's more likely to occur compared to things that are one of one, like the double six. So with this, he was able to point out that a red one and a green five is a different event from a red five and a green one, even though the results are the same. He was able to look at this in a broader, like, probability table and show how we can differ from the successes and failures when analyzing each event independently. Uh, we see this sort of recollection and this understanding for probability theory with the introduction of the works of James or Jacob Bernoulli, as he wrote The Art of Conjecture, where he broke it up into a series of parts. It was at the time considered incomplete for the fact of the matter that he had worked on the project for roughly 20 years and was always dissatisfied with how it was turning out. But it wasn't until sometime after that it was his nephew, if I wasn't mistaken, who went ahead and published the works. In which case, we saw a amalgamation of all these different concepts related to probability theory and how gathering them all together helped move things along to what we understand about it today. He took the works of other notable mathematicians like Christian Huygens, who we're going to touch on briefly at the end. Um, Considering all these problems related to game theory, this idea of more of these probable outcome chance based games in things related to what has already been gathered or established in the past, but also him creating some of his own problems that needed to be acknowledged for the reference of understanding probability better. Um, which we see the works of other mathematicians, particularly Pierre Simon Laplace, who went ahead and was criticized himself for some of the works that he put out for being these notoriously complicated works that only you know the most capable readers were capable of understanding. But it is with his production of the philosophy of probabilities that he was able to kind of strip away from the mathematical side of it and provide broader and clearer definitions for probability. Um, Providing it in the definition of a ratio in which you compare the possible chances of success or the total events of success to just the total events as a whole. This definition isn't a super unique or brand new concept, as even the works of Jacob Bernoulli and other mathematicians were able to surmise some type of definition akin to that, including Cardan. Uh, but he was the first one to put it in these broadest terms and also take it a step further by showing how these different operations occur when we consider mutually exclusive events as well as those independent events that we acknowledged earlier with the dice. Um, Probability has a very unique position in the world of mathematics in the sense of we often come across these universal truths through evident demonstrations and proofing, but we did see some backlash or some consequences that came with these developments, as a lot of the followers of Laplace were promulgating it as gospel truth in a sense that these equations, these formulas will guarantee an answer, and this is really difficult to consider when the reality of the matter is just it only shows what the circumstances are in an idealistic sense and how there can actually be this stark contrast between what we establish and actual empirical data. For example, if I have a d6, a six-sided die, and I roll it six times, there is no guarantee that I am going to get all six numbers to appear. And just because one number shows up more than the others, like say I get two threes or three fives, that also doesn't mean that five is favored above all else, and now it's just suddenly this magical lucky number. Um, and to kind of help show this demonstration, we circle back to Christian Huygens because there was one particular work that I want to point out of his, which was his development of mathematical expectation. He took the concept of, again, betting odds and probable outcomes and went ahead and constructed this formula to kind of dictate the justifiable pricing and value for a buy in whenever participating in these games. A big example, of course, is the gambling game roulette, where you go ahead and pick a number or a range of numbers, and whatever number appears on the roulette wheel will determine your payout should it line up. Uh, it kind of demonstrated how gambling as a whole or casinos as a whole went ahead and kind of skewed odds into their favors, and it kind of just takes a well positioned understanding of probability theory to be able to say that the best way to win the game is to simply not play. that's all the time I have for now. So I just want to thank you all so much for listening in, and I will see you next time. Thank you again.